Namaste, dear students. How are you today? Yes, you. I hope you all are fine. Today we are going to discuss about hydrocarbon and their compounds or its compounds. As you have already discussed in your earlier grades that there are many types of elements, which elements and these elements form different types of the compounds. Different types of compounds can be formed by the combination of different types of elements, as we are going to discuss today that the compounds which are formed by carbon, hydrogen and oxygen. These compounds which are formed by the combination of carbon and hydrogen along with oxygen atom, they are called the hydrocarbons. The hydrocarbons which we use daily in our daily life, uh, they can be like papers as well as other things. So all of these things will be discussed in our today's class. I think you all are ready to interact as well as to discuss as well as to listen today's class. Okay, are you ready? Yes. May I proceed ahead? Okay. Uh, at first, I'm just going to display some compounds, like these two compounds have been displayed over here. So at first you have to differentiate or identify the differences between the two compounds that have been displayed over the screen. So in the first compound, you can see here, in the first compound the compound is found or the found by the transference of the electron from this electron present in the valence shell, which have been just transferred to the another valence shell of the chlorine from the sodium. As well as in the second compound, we can see the electrons present at the valence shell of hydrogen as well as valence shell of carbon have been shared, as you have seen in the compound that this red spots indicate the electrons present in the valence shell of carbon, as well as the cross blue line indicates the electron present in the hydrogen atom. So these two that structures have shown the process of the formation of bond between the elements to give a compound. Okay, as in the first compound, you can see the bond has been formed by the transference of the electron from one atom to the another one. But in the second one, in this compound, you can see here the electrons have been shared to form their octet state or the duplet state. When the electron from the carbon as well as hydrogen has been shared, then you can see each hydrogen atoms of this compound have attained the duplet state, as well as the carbon has gained the octet state. So both of these hydrogen as well as the carbon, they have acquired the inert that state, that means the duplet state as well as the octet state. So just I am going to discuss on this on these compounds that the differences between that formation of the bonds. So in the first one, the bond has been formed by the transference, so it is called the electrovalent bond. Generally, the inorganic compounds form this type of bonds, but the organic compounds generally form this type of bond, because in such type of the compounds the bond between the elements are being shared. So the same thing has been seen over the second compound, that means in the methane. Okay, if it is so, then in the nature as well as in our surroundings, what type of compounds are found in the organic as an organic compound, as well as in the what type of substances can we find the inorganic substance that compounds. So we have to discuss over this, then we have to be clarified in these two things. So for this, I am going to show one experiment for you. That means you can see the things or the substances which can easily be burnt. Like you can see over the screen that in the first figure you can see the paper has been burnt. So, but if you try to burn the piece of metal, does it burn is that of the that paper burns? No, obviously not. As well as if you burn the that firewoods, then obviously it takes a bit longer time than the paper, but in the context of the iron, it doesn't burn, but the firewoods can easily burn. So what are the differences between these types of the compound that we are just going to show? I'm just going to show the that this experiment, then we will discuss on the differences on the elements present over these two types of the compounds. So for this, I'm going to show the experiment. Please pay your attention towards the experiment, please. Okay, I'm just lighting this candle. So itself, this matchstick is being burnt. It means it is also one of the organic compound, because organic compounds generally burn quite easily, is the inorganic compounds does not burn easily. So I'm just burning this paper. Yes, like this. Just you can see here. It is how fast does this paper does that burn. So you can see, but if I try to burn this spatula, does it burn as easily that of the candle, that paper? Obviously not. So yes, I'm just trying to burn it. Then how long does it take to burn? Can you imagine? So these two differences are being found in the organic compound as well as the inorganic compounds. So this is all about the experiment. Just I am trying to convince you that on the that property of the hydrocarbon. Okay, just you have seen the differences between the combustible nature of the organic compound as well as the inorganic compound. It means the organic compounds can easily be burnt, that means they are quite combustible, but the spatula, which is made up of the iron, it is not combustible as the paper's property has. So these are the differences on the basis of the burning nature. Like this, we can show the differences between the other that properties of the organic as well as the inorganic that substances. So on the basis of the nature of the bond, as I have already talked about, that the organic compounds have been formed by the sharing of electrons. So for this, there are many types of the organic compounds. On the basis of the number of carbon atoms present over the organic compounds, they have been classified according to the that methane as well as ethane as well as propane and butane and so on, because there are innumerable alkanes, that means the hydrocarbons. Just you can see over the screen that we are introducing the hydrocarbons. So for this is I have already shown to you that the experiment. So for the same, just I am trying to show this structure also. So this is the methane, because this black bulb indicates the carbon as well as the pink colored bulbs that are being just aligned aside. They have been just they are the bond. So just I have made it by the help of clay. So I have just taken the help of the pins also, bamboo pins. So they have been just done like this. So in one carbon atom, you can see altogether 4 hydrogen atoms have been shared. How these 4 that hydrogens are being shared is I have already shown to you that the carbon has 4 electrons in the valence shell. Is I'm just you can see over the that whiteboard that okay. So carbon has 2 electrons at the first cell as well as 4 electrons at the second cell. So it requires 4 more electrons to be octet. So for this, it shares with the hydrogen 1 electron, as well as there are another hydrogen atom also, as well as another hydrogen atom, and the fourth one. So the black spots indicate the electron present in the hydrogen, as well as the that white balls indicate the electron present in the valence shell of the carbon. So altogether, if you count 1, 2, 3, 4, 5, 6, 7, 8. In the valence shell of carbon, there are 8 electrons, as well as in the hydrogen there are 2 electrons. For the same, just the model of the methane. So this is all about the methane. So this is structure. So for this, these electrons, thus these two bonds, so this is the bond. So it has been shown by this one. This is the bond. Just it has been just joined from carbon to hydrogen. Is like this. You can see over here. Methane has 1 carbon atom as well as 4 hydrogen atoms. But in the another one, you can see these 2 balls are for the carbon atoms, as well as 1 carbon atom bears altogether 4 bonds. So that means 1 bond has been shown towards the another carbon atom, as well as 3 bonds have been shown towards this carbon atom, hydrogen atom, as well as this hydrogen atom, as well as this hydrogen atom. So altogether, this carbon has shared 4 electrons, which are present at the valence shell. As well as in the second one, you can also see here that the carbon has shared 4 electrons. So altogether, there are 2 carbon atoms. So 2 carbon atoms have shared, or they need altogether 6 hydrogen atoms. So it has been shown like this. It can be represented by this. These white balls indicate the hydrogen, as well as the black balls indicates the carbon atoms. So altogether 2 carbon atoms, as well as 1, 2, 3, 4, 5, 6 hydrogen atoms. You can see over the screen also. Okay, in these structures, you can see the black balls indicate the carbon, because the model that you have been seen here, that is, this is the atomic model of carbon. So the same that ball has been represented by this black ball, as well as in the another one. This is also carbon, and this one is also the carbon. So carbon is the fundamental element that forms the organic compound. This is the gist, as well as this is the significance of these structures seen over this screen. Okay, organic compounds can be of different types. You can see here. This is the wood. Wood is made up of carbon, hydrogen, and oxygen, because this is the chain of the cellulose. Cellulose consists carbon, hydrogen, and oxygen. As well as you can see in the next one, this is the graphite. This graphite is used in the pencils. So this is another type of the organic compound. As well as kerosene. Generally, kerosene is the petroleum or the fuel which is used to burn which is used as the source of the energy, light energy. As well as this is the cartoon. Yeah. So cartoon is also a kind of a form of the organic compound or the hydrocarbon, because this is also a very light as well as very thin that film which is made up of that natural products like this wood, as well as other that bamboo pieces and so on. So so this is all about the introduction. Now we are just going to discuss about the types of the organic compound, because there are millions types of the organic compound on the basis of the different properties. We are discussing about the types of the organic compounds on the basis of number of bonds present in the carbon atoms. So on the basis of different types of the properties, there are many types of the organic compounds. So but on the basis of the number of bonds present between carbon and carbon atoms, there are 2 types of the organic compounds are there. They are saturated as well as the unsaturated hydrocarbons. Saturated in the sense of that no more that addition of other species are possible. That means I have already shown you that there are altogether in this structure you can find altogether there are 4 electrons in the valence shell of the carbon atom. So out of these 4 electrons, these all are occupied to share with the hydrogen atoms. No more possibility is there to add other species, that means other hydrogen atom or any other halogen atoms and so on. So this type of that hydrocarbons in which there is no possibility to add other species, they are called the saturated. As we used to just relate with the saturated solution, that the solution in which no more solutes can be dissolved is like the same the hydrocarbon in which no more species are possible to add over the hydrocarbon, they are called the saturated. In the same sense, we can just relate with this unsaturated hydrocarbon also, as we use to define the unsaturated solution that at a particular temperature, no more solutes can be dissolved over the solution. Such type of solutions are called the unsaturated. I think you all are familiar with this term. Okay. In the same that sense, we can just relate this term with the hydrocarbon also. That means if there are possibilities to add some more species like hydrogen as well as other halogen and so on, they are called the unsaturated hydrocarbons. So we are just going to I am going to show the examples. You can see over these examples that in the first one you can see carbon, this carbon and this carbon, they are being bonded with two bonds. It means this is the double bond. So if one bond is broken, what would happen? Yeah, there is the possibility to add other species. You are correct. In the next one, that means you can see under this alkyne, there are three bonds between carbon and carbon atoms. If two bonds are being broken, let's suppose if two bonds are being broken, is there other possibilities to add like hydrogen as well as other halogen atoms? Yes, exactly. There are possibilities to add other species also. So in this condition, or in by showing this type of properties by these two compounds, they are kept under the unsaturated hydrocarbon. But if you try to add some other species in this one, does this compound add other species? Impossible. Yes. So due to this, there is no possibility to add other species other that like hydrogen as well as halogen. So this is called the saturated, because saturation means there is no possibility to add other species. Yes. So this is all about the types. If you are just aware on these two things, then obviously it is quite clear for you. It is enough for you to know about the saturated as well as the unsaturated hydrocarbons. Okay, let's move ahead. You can see here that this blue bulb, which is at the middle of the other bulbs, this represents the carbon atom, and this carbon atom has made 4 bonds, 1, 2, 3, 4. So there is no possibility of addition of other species. So it is under what? Saturated. So generally the saturated hydrocarbons are also known as alkanes. In other words, they are also known as the paraffins. To represent such type of hydrocarbons or the saturated hydrocarbons, we use a formula, that is Cn as 2n plus 2, in which n represents the number of carbon atoms. So let's talk about this the methane, how the this molecular formula is just related with this methane. Just I am trying to calculate it and show you. Cn as 2n plus 2, where n represents the number of carbon atoms. For example, in methane you can see only one carbon atom, that means C1, then H, if you supply the value of N1, then you will get 2 into 1 plus 2 is equals to CH, 2 1 is 2 and plus 2 equals to CH4. This is the way to write the molecular formula of the alkanes. So this Cn Cn as 2n plus 2, this is the general molecular formula to represent the saturated hydrocarbon, that is the alkanes. Now we are taking another example, ethane. Can you just relate this C2H6 with Cn 2n plus 2? Yes. Supply the value 2 because ethane has 2 carbon atoms. So if you put 2 for C, then H 2 into 2 plus 2 equals to 2 to the 4 and 2 equals to 6. So altogether you will get this structure. or this molecular formula. So in this compound also you can see there are 2 carbon atoms as well as 1, 2, 3, 4, 5, 6. 6 hydrogen atoms have been bonded with 2 carbon atoms. So structurally it can be represented by this one. This is the structural formula of ethane. This is the condensed formula of the ethane, as well as this is the model of the ethane. Okay. In the same way we can just make the structure of propane also. That means propane means there are 3 carbon atoms. So if there are 3 carbon atoms, then obviously it will give C3 and H8. So you can see here 3 carbon atoms, 1, 2, 3, and altogether 8 hydrogen atoms over this that periphery, which are bonded with the each carbon atoms, because each carbon atom has made 4 bonds, 1, 2, 3, 4, as well as in the structure also you can see 1, 2, 3, 4, 3 with hydrogen atoms as well as 1 with another carbon atom. And by the same way we can prepare, we can make, or we can see, we can study the other structure of other saturated hydrocarbons like butane, pentane, hexane, and so on. Just you can see butane. Can you relate this molecular formula with CnH2n plus 2? Dear students, please do in your, just relate with in your copy and just try to write the structure, try to just write the molecular formula to represent with or to relate with CnH2n plus 2. Obviously you will find the C4H10 would be the correct molecular formula for the butane, because butane represents the 4 carbon atoms, C4, then H, 2 into 4, 4 to the 8 plus 2, 10. So you will get C4H10 as a molecular formula of what? The butane. Similarly, you can just find the molecular formula of pentane. Pentane means you can see altogether 5 carbon atoms, 1, 2, 3, 4, 5. Yes, the blue colored balls represent the carbon atoms in this structure, as well as white balls represent the hydrogen atoms present over the carbon. So this structure is being written here in linear form. That means this is the way to write in your answer sheet as well as in your note copy also. So altogether you will find 5 carbon atoms with 12 hydrogen atoms here. So this is the structure of pentane. So in all these structures, I think you find the similarity. That means the carbon between the carbon and carbon atoms, you looked the same number of bonds. That means single bond. So single bonded hydrocarbons. That means if you find the bond between carbon and carbon atom, a single bond, that means they are the saturated hydrocarbons. So they are also known as the alkanes. So these are all about the alkanes that we have just discussed today. So on the basis of these discussions, I have just brought some questions for you for your that evaluation. That means how you learn on this class. It will be evaluated by the questions that will be discussed in the next. So one question has been displayed over the screen. That means which of the following is saturated hydrocarbon? So what is the way, or what is the basis to find the saturated as well as unsaturated hydrocarbon? Yes, if you see the bond between carbon and carbon atom is the single one, obviously they are called the saturated hydrocarbon. So if you go in the first option, you will find there are double bond between this carbon as well as this carbon. So it does not fall upon the saturated, because there should be, if you are looking the single bond between this carbon and this carbon, but if you find a single bond, single double bond between carbon and carbon atom, obviously it is fall upon what? The saturated. So in the second option, CH3 and single bond, but in the second one you will find the triple bond. So this is also not that fall upon the saturated. In the third option, you can find there is single bond, and the single bond. What does it mean? Okay. In all carbon atoms, you are looking the single bond. So this is the way to find the saturated hydrocarbon, or this is the correct option. And the fourth one, you are looking the between this carbon as well as this carbon atom, there are double bonds. Obviously, this is not the saturated, because there is the possibility to add other species over this fourth one also. So which one is the correct answer? Yeah, C, correct. Next one. Okay, which of the following is correct about the information given in the table? There is a table in which some informations about the number of carbon atoms as well as the name of the compound have been given. So the first column represents the number of carbon atoms, as well as second column represents the name of the compound related with the number of the carbon atom, because the name of the hydrocarbons have been kept on the basis of the number of carbon atoms. They are the different. As you have discussed in today's class that in ethane, how many bonds, how many carbons did you just find at that time? Yes, 2. In the propane, 3. In butane, there were 4 carbon atoms. So just you have to match these relations. So if you go through the first option, A1, that means 2 carbon is butane. The hydrocarbon which has 2 carbon atoms, does it represent the butane? No. If the first one is incorrect, it is not necessary to see other that relations. So in the second option, you can find C3. C3 means, that means 4 carbon atoms and propane. Is it the correct relation? Obviously not. In number third option, A2, that means first option is related with these 2, that means 2 carbon atoms, the hydrocarbon which has got the 2 carbon atoms. Is it related with the ethane? Yes. Then you can move into the next one, B1. If there are 3 carbon atoms, does it call the butane? No, it is also incorrect. Okay, let's go into the fourth one. A2, that means A is related with 2. Is it correct? Yes. And B3, the hydrocarbon which consists 3 carbon atoms, it is called propane. Yes, correct. In the C1, that means the hydrocarbon which has 4 carbon atoms, it is called the butane. Correct. So this fourth one is the correct option. I think you also have put the tick on the fourth option. Okay, well done. Now we are moving towards the other questions. You can see here, which of the following statement is related to saturated hydrocarbon? You can read the statements A, B, C and D. The statements have been given in 4 points. Then you have to choose the correct answer. That means saturated hydrocarbons, they have single bond between carbon and hydrogen. Is it the correct? If do we find the hydrocarbon as a saturated on the basis of the number of carbon hydrogen bond, number of the bonds present between carbon and hydrogen? No. And you can see the second option, they have double bond at between carbon and carbon atom. Is the correct one? Oh, obviously not. If the bond between carbon and carbon atom is double, obviously it is the unsaturated. It is not the correct one. Third option, they have single bond between carbon atoms. Yeah, this is the correct option. They need hydrogen atoms to be saturated. If the hydrocarbon needs that hydrogens to be the saturated, is it the saturated one? Do you believe on this? No. So this C is the correct option. I think, I hope you all have put the tick on the option number C. Okay, this is the correct one, because in today's class we have discussed about different types of the hydrocarbons, and the hydrocarbons are related with the number of the bonds present between carbon and carbon atoms. And another question, just we are talking about the subjective questions. Write any two examples of saturated hydrocarbons. Can you give? Please write down in your copy, in your copy, please, and try to submit to your teacher. Another one, why is the key? What is the key feature to recognize the saturated hydrocarbon? Yeah, please, you can write. So the key feature to recognize or to identify the saturated hydrocarbon is you have to see the bond between carbon and carbon atom of the hydrocarbon. If you find the single one, then what is it? Yeah, this is the saturated. Another question, in laboratory, a researcher try to make a reaction between ethane and hydrogen, but they do not react. What could be the reason? Because both of these two compounds are the saturated. There is no possibility to be added to each other, because if there is the possibility, if these two compounds react to each other, then they should have got the unsaturated or the double or the triple bonds. Next one, study the following chemical equations. Just you can study. And the first one, CH3, CH double bond CH2 plus H2, and it has been given. Then what could be the product? And CH3, CH2, CH3 plus H2, it has been given over here. Then a question has been asked for you that out of these two compounds, in which reaction is possible, or out of these two equations, in which reaction or in which equation reaction is possible, and why? Okay, this addition of hydrogen in the second one, is it possible? No, because this is the saturated hydrocarbon. As you have discussed, if you see the single bond between carbon and carbon atom, they do not react, or such compounds do not react because they are the saturated one. But in the first one, if you see this first one, you can see the double bond between carbon and carbon. Then there is the possibility to add. So obviously, this first equation that you have seen over the screen, the reaction is possible. But in the second one, it is impossible. Have you written the same thing over in your copy? Yes, well done. If you have written the same thing, it is the correct answer. Finally, I have brought a project over for you. As I have shown at the time of discussion, different types of the model, different types of the models of saturated hydrocarbon like methane, ethane, propane, butane, and so on. Just prepare such type of the models by taking the clay. You can take the clay, as well as you can just take the paper. Just you can just mix with the water, then so that it will turn into that semi-solid form, which can be molded into the different types of shapes. Like you can make or you can prepare the balls. Then by the help of the other that sticks like toothpick, also you can take other that bamboo the sticks also you can take. So by taking these materials, you can prepare the models like methane, ethane, and butane and submit to your teacher. Yeah. Okay. How did you find today's class? I hope you all enjoyed in my today's class, and hope you will do the project works as well as other that necessary exercise from your book also. Then submit your teacher, and please do your best in your that future career. Thank you for today's class. Thank you.